Welcome back to IB ESS. This is climate change and the greenhouse effect. The natural greenhouse effect, why human activity enhanced it, and what rising temperatures mean for global systems. One of the biggest topics in the whole course. Distinction matters for exams. Weather, short-term atmospheric conditions, day-to-day, hours to weeks. Examples, temperature, wind, rain, snow. Climate, long-term average of weather patterns, decades to centuries, even millennia. Weather varies wildly hour to hour. Climate shows clear trends over decades. When you answer exam questions about climate change, you're talking climate, not weather. How Earth's atmosphere traps heat. Incoming solar radiation enters. Albedo reflects some to space, clouds, ice, atmosphere. Surface absorbs 70% and re-radiates heat upward as infrared radiation. GHGs in atmosphere absorb this infrared. Enhanced warming radiates heat back to surface. Result: without greenhouse effect, Earth is minus 18 degrees Celsius. With it, life-sustaining 15 degrees Celsius. Natural greenhouse effect is essential for life. Don't confuse that with the enhanced effect. That's the problem. 5 main ones. CO2, fossil fuels, deforestation. Atmospheric lifetime, 100 to 300 years, 76% contribution. Methane, CH4, livestock, rice paddies, landfills. Lifetime, 21 years, 16% contribution. Nitrous oxide, N2O, fertilizers, combustion, industry. Lifetime, 121 years, 6% contribution. HFCs and water vapor. Critical insight. CO2 dominates because of volume and persistence. Methane is potent but shorter-lived. N2O is potent but low concentration. Exam questions test whether you know why each contributes. Pre-industrial. CO2 280 ppm. Present day. 423 ppm. The curve is famous. Go to slide 8 and describe the seasonal oscillation. Human activities. Fossil fuel combustion, deforestation, agriculture, industrial processes release GHGs. More GHGs trap more heat. Surface warming plus 1.2 degrees Celsius from 1900 to present. The positive feedback amplifies warming. More evaporation, less ice reflecting sunlight, more absorption. That's the enhanced greenhouse effect in one sentence. Humans added extra GHGs, intensifying natural heat trapping. Feedback amplifies warming. Albedo feedback. Warming melts ice and snow, exposing darker ocean and land that absorb more heat, causing more melting. Water vapor feedback. Warming increases evaporation. More water vapor traps more heat. Warming accelerates. Permafrost CH4 feedback. Warming thaws frozen soil, releases methane, traps more heat. Climate sensitivity is higher because of these positive loops. Each degree of warming triggers more warming. Negative feedbacks resist change. CO2 fertilization. More CO2 promotes plant growth. Plants absorb CO2, slightly counteracting increase. Cloud feedback. Warming increases clouds, which reflect sunlight, but also trap heat. Complex and uncertain. Tipping points are thresholds. Once crossed, unstoppable change occurs. Arctic sea ice. Positive feedback so strong that if ice is lost below critical threshold, the feedback loop becomes self-sustaining. Amazon rainforest. If deforestation exceeds 20 to 25%, the system flips to savanna. Permafrost. Thaw releases massive CH4 stores. These aren't reversible in human timescales. Real and documented. Island nations. Tuvalu, Maldives face 1 meter sea level rise. Heat waves amplify mortality in India, Middle East. Caribbean, stronger hurricanes. Great Barrier Reef, acidification, coral bleaching. Sub-Saharan Africa, drought, crop failure. Tropics, malaria expansion. Himalayas, Alps, glacier melt threatens 1.2 billion people's freshwater. Siberia, permafrost thaw releases methane. Unequal impact. LEDCs suffer most, though they caused least. That's the equity issue. 3 worldviews shown. Ecocentrism, climate emergency, act immediately, transform economy. Anthropocentrism, serious concern, managed transition, balance economy and environment. Technocentrism, technology will solve it. Continue growth, deploy geoengineering later. Which should guide policy? The exam asks you to evaluate. Ecocentrism prioritizes ecosystems. Anthropocentrism balances interests. Technocentrism assumes solutions exist. Evidence suggests ecocentrism's timeline is more scientifically defensible, but implementation is politically hard. IPCC temperature projections, 1900 to 2100. Multiple models converge. If emissions continue, RCP 8.5, warming reaches +4 degrees Celsius by 2100. If emissions cut, RCP 2.6, warming limited to +1.5 degrees Celsius. Why spread? Models differ in climate sensitivity, feedback strengths, emissions assumptions. Input, emissions scenarios and known physics. Process, weather systems simulated over decades. Output, temperature projections with uncertainty ranges. Validation, model accuracy improves as atmospheric conditions and historical data accumulate. Uncertainty doesn't mean the science is wrong. It means we can't predict exact location and timing of impacts. The direction and magnitude are clear. Weather versus climate. Natural greenhouse effect. Enhanced greenhouse effect. 5 key GHGs with atmospheric lifetimes. Keeling curve and seasonal oscillation. Positive feedbacks amplify. Tipping points. Arctic, Amazon, permafrost. Regional impacts and unequal burden. EVS perspectives. Ecocentric, anthropocentric, technocentric. Climate models with uncertainty ranges. Explain each with examples. Exam ready. Question 1. Explain the difference between the natural and enhanced greenhouse effect. Question 2. Evaluate positive and negative feedback mechanisms in the climate system. Pause now. 10 minutes for both questions before continuing. You understand the science of climate change. Now we tackle solutions. Mitigation, adaptation, international frameworks keeping warming below 1.5 degrees Celsius. The science is clear. The challenge is implementation. Easy ESS continues.